This is lesson 10.5, part 1. We're looking at hyperbolas with center at the origin. Okay, so in a hyperbola, I'm just going to write a few things on top here. A is still the distance from center to vertex. And in these hyperbolas, this is the center for this lesson, and these are your vertices. So center, vertex, vertex. So A is the distance from center to vertex. Distance from center to, squeeze that there. Distance from center to vertex. And in these hyperbolas, the focus is that there's two. The foci are both inside the bowl. And these are called branches. So the two curves are called branches. So in this one, the two foci would be right there. I'll label them with an F. So the distance from center to focus is called C. It's the same as we've been doing. So C equals distance from center to focus. Okay, so let's maybe start filling out this table and fill in the picture a little bit. So the first thing, the segment that lies on the line containing the foci and has endpoints, and the vertices are also called endpoints. So the segment that lies on the line containing the foci and has endpoints on a hyperbola, that's called the transverse axis. Transverse axis. So this is our transverse axis for this one, and this is our transverse axis here. So notice when they're facing out, the branches are facing out sideways, we have a horizontal transverse axis, and when the branches are going up and down, we have a vertical transverse axis. Okay, and as we said, the endpoints are the vertices. So the endpoints are the vertices of the hyperbola, and I'm going to put a V. Let's put V's for the vertices. So V. Okay, so the midpoint of the transverse axis, so here we go, and the foci is at the center. So we'll say that's the center of the hyperbola. So for this lesson, the center is at the origin. Next lesson, it'll start moving. And the last one is the blank intersect at the hyperbola center. Now, what we're going to put here is the asymptotes. Oh, too many O's. Asymptotes. And we'll look at those when we start doing examples, but the asymptotes, I'm going to try to sketch some in here so you can see. What the asymptotes are lines which the branches of the hyperbola follow. So I'm just going to sketch in some asymptotes so you can get a feel for them. Okay, so those are my asymptotes, not drawn very well, and it should have gone, and this really should have passed right through the center. So if you're doing this, try to get it to pass through the center. So you want it to hug the branches, pass through the center. And of course this is a little easier when we have graph paper. So for this one, since we said that A is distance from center to vertex, the vertices are going to be at negative A0 and A0. So this is A0, negative A0. And negative A0. And our asymptotes, these are the equation for these lines is y equals plus or minus a over b x. Okay, so there's two lines, so there's y equals a over bx, which is the positive, y equals negative a over bx, which is the negative. So when we have a vertical transverse axis, my vertices are now at 0a and 0 negative a. So this is 0a, this is 0 negative a. And the equation for my asymptotes, which are the equation of a line here, is going to be y equals plus or minus, but now instead of a over b, this one, so this is a over b x. This is a mistake. This needs to be b over a. Because we always do in an equation of a, remember this is our slope, and slope is change in y over change in x, and as we graph them it might make a little more sense, but we do y over x, so b over a, and then this one's a over b. So let's put some numbers in here, hopefully it makes it a little bit more clear. So number one, we're going to try to graph this hyperbola. Now notice that just like the ellipses, it has to be equal to 1. We need an x squared, a y squared, and it has to be equal to 1. The different thing is that we now have minus instead of plus. So with hyperbolas you always have a minus between them. And with hyperbolas the a does not have to be bigger than b. So that being said, I need a 1 here. So I will divide each piece by 144. So I now have negative y squared over 9 plus x squared over 16 equals 1. I want it to look like this, not necessarily putting the x first, but I want it to be positive term first, negative term second. So I'm going to say x squared over 16 minus y squared over 9 equals 1. Now let's start to graph this. Notice that in our formula here, a is always under the first term. So that means that my a here is going to be 4. And I know I haven't brought up b yet, but I think b is easier to illustrate with an example. So b, which is right here, is going to be square root of 9. b is 3. So we have enough now to graph. So once again, this whole section are centers at the origin. So put my center in. Now, how we graph these things is we're going to make a box, we're going to draw some asymptotes, and then we're going to sketch along those asymptotes. So let's go through it step by step. So first thing is to make our box. So a equals 4, and that's in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. And b equals 3, that's in the y direction. 1, 2, 3. 1, 2, 3. Alright, so now I'm going to use my points and sketch a box. Now I'm going to use my box as a guide to draw in my asymptotes. So I'm going to use a straight edge, and I'm going to connect corner to corner of my box and draw a line through it. And I'll do the same on the other side. Corner to corner, draw a line through it. Alright, these are my asymptotes. Now, since my x term is first, I know I have a horizontal transverse axis, which means I'm going to open up to the sides. And that's again because my x term is first. So I'm just now going to start at my vertex and use my asymptote as a guide and sketch this out as best I can. Okay, and now we've graphed it. Now, in a few more questions, we're going to start making sure we put a focus in, the foci in, but for now, let's just work on graphing these. So for this one, remember that the a term is always underneath the first term. So a equals the square root of 4, which is 2, and b equals the square root of 16, which is 4. And now I'm going to use a and b in graph. So I'm going to go 2 units in the y direction from the center. Center is at the origin. 1, 2, 1, 2. 4 units in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. And sketch the box. So notice in this example that a is smaller than b. I'm completely fine with hyperbolas. And then I will put in my asymptotes, corner to corner. And since this one starts with my y squared, it's going to have a vertical transverse axis. So I will sketch in my branches. Trying to hug my asymptotes. And these go on getting infinitely spread out. Arrows on the end. Alright, and there is our hyperbola. Now we can take a look at how to use the foci, how to find the foci. So the foci always lies on the line containing the transverse axis. And remember we said the distance between the foci and the center is c. And now we're going to use this equation to find the focus or to find A or B. So notice this one is very similar to the formula we use for ellipses, except for in this one we're using A plus B, and for ellipses we used A squared minus B squared. So I'll just keep doing what I was doing. A is going to equal 6. B is going to equal 2. I'm going to start graphing. So center at the origin, 6 in the x direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 in the y direction. 1, 2, 1, 2. Sketch your box. Asymptotes. Okay, horizontal transverse axis. And I should not have crossed over that asymptote. Never cross the asymptote. My hyperbola. And now I'm going to find the foci. And I will do it using this equation. C squared equals A squared plus B squared. A squared is 36. And B squared is 4. So C squared equals 40. Take the square root of both sides using only the positive results. I get C equals 2 square root of 10, which is approximately 6.3. So now I can sketch in my foci, which are always along this axis here, along your transverse axis. So I'm going to go out 6.3 from the center. 1, 2, 3, 4, 5, 6.3. And the other one should be right here. And there are my foci. And the coordinates, I'm going to do F. The coordinates of my foci are, so it's 2 rad 10, 0 and negative 2 rad 10, 0. So I'll just call it plus or minus 2 square root of 10, 0. So I've graphed and I've found the foci. Alright. This one, I don't need to complete the square. I don't know if it might look like I do. I don't, because I don't have any y term of degree 1. All I have is a y squared. Same thing with x. All I have is an x squared. If I had a regular x term or a regular y term, I would need to. So I'm going to get my x and y on one side, constant on the other. So I'm going to add 2 to both sides of this equation. So I have (9) y squared minus 4x squared equals 36. I need this to be 1, so I'm going to divide everything by 36. I have y squared over 4 minus x squared over 9 equals 1. So center at 0, 0, 2 units in the y direction, 3 units in the x direction, and I'm going to graph my hyperbola. Okay, vertical transverse axis. A equals 2, B equals 3, C squared equals 4 plus 9. So C squared equals 13. And C equals square root of 13, which is about 3.6. So 1, 2, 3.6, 1, 2, 3.6. There's my foci, and they are at 0, and then at plus or minus square root of 13. Alright, write an equation for a hyperbola with vertices at -5, 0, and 5, 0, and conjugate axis of length 6. We haven't used the word conjugate axis yet. I think it should be clear what that is. That's the other axis. So in this case, this is my conjugate axis. Here, this is my conjugate axis, and it just goes from center to that B point, center to B. So before I do this, as with all of these conic sections, I am going to do a sketch. So I have vertices at -5, 0, 5, 0, 2, 4, 5. And my conjugate axis is length 6, which means 3 above the center, 3 below the center. Okay. This is just a sketch to give me an idea of what I'm doing. Okay, so since my vertices are here and here, I know it's going to open up horizontally. Okay, and I also know, since it has that horizontal transverse axis, that my equation will be of the form x squared over a squared minus y squared over b squared equals 1. Okay, and I know that A is 1, 2, 3, 4, 5, and B is 1, 2, 3. And I can just plug those right in. X squared over 25 minus y squared over 9 equals 1. Alright, Write an equation for a hyperbola with vertices at 0, 4, and 0, negative 4, and foci at 0, 7, and 0, negative 7. So again, I will make a sketch. I'm going to make it over here. So vertices at 0, 4, and 0, negative 4. Alright, since these are my vertices, I know that I'm going to have a vertical transverse axis. So it's going to open like this. Okay, and then I have foci at 0, 7, 0, negative 7, so 4, 5, 6, 7. 4, 5, 6, 7. There's my foci. So from here, I'm just going to do this again. I'm going to write out my equation, only this time, since I know I have that vertical transverse axis, I'm going to have y be my first term. So now I have y squared over a squared minus x squared over b squared equals 1. So let me see what I have and what I need. A, distance from center to vertex. It's going to be 4. I don't know B yet. C, distance from center to focus, is going to be 7. Now I can use my formula to find B. C squared equals A squared plus B squared. So 49 equals 16 plus B squared. So 33 equals B squared, and square root of 33 equals B. And you don't have to graph it. I'm going to finish the graph. So that is about 5.7. So I'm going to go out 5.7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So now I have a little sketch. So now I have B and I have A, so I can just plug it in. Y squared over 16, 4 squared, minus x squared over 33, which is radical 33 squared, equals 1. And that is the end of part 1 for 10.5.